Hello, my name is Megan Davis. I am an ASCP certified medical laboratory technician with about 7 years of bench experience. And today I'm here to talk about prion detection assays and their potential use in transfusion medicine. Here's a lovely poster. Convert that to digital, make it a little easier for everyone to see. So why prions? As we know, prions are misfolded proteins that can act as viruses. Free circulating prions can interact with biologic normal proteins and elicit also misfolding. These clusters of misfolded proteins, called aggregates, have a tendency to settle into neural tissues, disrupting the electrical input and output signals, and can create neurodegenerative disease states in humans, such as Creutzfeldt-Jacobs disease, Parkinson's disease, and Alzheimer's. Theories suggest that prions can be transmitted through tissues, yet no surveillance study has yet to be conducted on evaluating whether or not prions in misfolding proteinopathies are present in blood products within our nation's blood supplies. The objective of this surveillance study is to address the gaps in donor blood product testing prior to transfusion. Currently, the American Red Cross to date does not require donor products to be screened for prions and protein misfolding proteinopathies. The surveillance study will use two assays that are currently being used in neurodegenerative disease research: neurofilament light chain protein assay and also real-time quaking-induced conversion assay. The screening assay will be neurofilament light chain. It uses EDTA plasma. The theory behind the methodology is the increased quantitation of these free circulating neurofilament light chain proteins in EDTA plasma correlates with an increased severity of neural tissue damage. For the confirmatory assay, real-time quaking-induced conversion assay, which is also called RT-QuIC, uses CSF. The methodology involves a matrix that has coded seeds of prion particles that, through cycles of rest and agitation, if there are any free circulating misfolding proteinopathies within CSF, these beads will actually elicit folding, create aggregates. The fluorescent substrate produces a signal that is then converted into a quantifiable result. Both of these assays have demonstrated increased sensitivity and specificity of greater than 95% confidence limits. The study will be broken down into three distinct phases. Phase 1, screening and confirmation. Phase 2 is going to be recipient monitoring, and phase 3 will be product data analysis. In phase 1, the screening and confirmation, there's going to be 5 pre-selected donor sites from major metropolitan areas, and each will submit 200 unknown specimens from each site, totaling a number of 1,000. There's going to be 100 positive control group from positively diagnosed neurodegenerative diseased patients, and also 100 negative specimens for our negative control group from confirmed negative patients. All blood donor products will be traced using a barcode identification system that we're all familiar with in transfusion. And RT-QuIC will also be used as a confirmatory for any positive identified donors. And the purpose of the statistical analysis is to break down the percentage of positively identified donor products by each individual region that is selected. This can glean information about possible cluster infections for later epidemiology studies. Phase 2 is recipient monitoring. So once any positive blood donor products have been identified, the recipients of those products will be screened at initial using the neurofilament light chain EDTA, and then up for 10 years or until a positive detection. Any recipients that are positive, their blood product type will be submitted for statistical analysis along with the time it took for a positive ID. For phase 3, the product data analysis, this is where all the information comes together. The specific type of blood product, whether it's leukocyte reduced, non-leukocyte reduced packed cells, platelets, and plasma, they will be categorized as such. And also the time from a positive identification, either at initial screening, 1 to 5 years, or 5 to 10 years. Any correlational data will be analyzed using the Pearson-R method, with the lowest detectable limit rate measured against the confidence limit of 0.05. And here's where the positive and negative control group quantitations will come into play as being used as our determined cutoff levels using receiver operating curves. And here's a graphic representation of the statistical analysis. Non-leukocyte reduced versus leukocyte reduced packed cells have been individually identified from animal study trials performed already, where there has been correlational data that the non-leukocyte reduced packed cells had a higher incidence of transmission of prions versus the leukocyte reduced. Researchers are continuously studying why and what about the leukocytes that the prion has a tendency to anchor towards. And in conclusion, the surveillance study evaluating neurofilament light chain protein and RT-QuIC assays for use in transfusion medicine serves to address several objectives, addressing key gaps in patient donor product testing. Also, the data generated can be useful to further prion research into anything from transmission rates, incubation times, to even regional cluster outbreaks that can be indicative of other issues going on in metropolitan areas. And also the key objective is to serve to ensure the safety of the nation's blood supply by continuously monitoring these life-saving products in the wake of the multitude of ever-challenging environments of blood-borne pathogens, such as prions and others. And I've set in some further information about prions from the CDC, any Red Cross protocols, and also other studies that I have used in formulation of this surveillance study. And I would like to thank everyone for watching. Thank you so much, and have a great rest of your semester.